Hello students, our next topic is Hasse diagrams. So Hasse diagrams are nothing but the diagrammatic representation of posets. So what are posets? We already have studied it previously. So the relations which follow the properties of reflexive, antisymmetric and transitive, those are called as posets. So we'll see the significance of posets one by one. So first point is that the vertices in the Hasse diagram are denoted by points rather than circles. Since a partial order is reflexive, we know that it's reflexive, each vertex of A must be related to itself. Hence, the edges from a vertex to itself are deleted in the Hasse diagram. That means self loops are removed. Since the partial order is transitive, hence, whenever A is related to B and B is related to C, we have A is related to C. So we eliminate all edges that are implied by transitive property in the Hasse diagram. That means delete edge from A to C, but retain the other two edges. That means A to intermediate vertex and intermediate vertex to C. That is retained, but direct arrow from A to C is deleted. Next is that if a vertex A is connected to B by an edge, that means A is related to B, then the vertex B appears above vertex A. That means if this tuple is in my relation, that means A is related to B. So what they are saying is that the vertex B should be above vertex A. Okay, that means the left element should be below the element at the right. So as this is already assumed, therefore the arrow may be omitted from the edges in the Hasse diagram. That means we are omitting the arrows. Okay, as we know that the vertex below is related to the vertex above. If two elements P and Q are non-comparable, that means there is no such tuple P and Q in the relation R. Then they lie on the same level and there is no edge between P and Q. And finally, if P is related to Q, then join P and Q by an edge, but point P appears lower than point Q. So these are all the points related to Hasse diagram. You can just read them again or note them down and we can move on to the example. Now, moving on to an example. So this is the poset given to us. This is my set S and this is the relation. The relation is less than equal to relation. How can I define the relation R? So here 1 is less than equal to 1, 1 less than equal to 2, 1 less than equal to 3, 1 less than equal to 4, 2 less than equal to 2, 2 less than equal to 3, 2 less than equal to 4, 3 less than equal to 3, 3 less than equal to 4, and 4 is less than equal to 4. So this is my relation R. This is a poset. You can verify it yourself. Now I have to draw the Hasse diagram. So we already know how to draw the diagram of any given relation R. So firstly, I am drawing the diagram of R. So it will look like this. As you can see, 1 is related to 1. This is the arrow. 1 is related to 2. 1 is related to 3 and so on. So this is the diagram. Consider this as points rather than circles. Okay. Now, what is the first step? First step is you have to assume that self loops are implicit and remove them. Self loops are this: 1 is related to 1, 2, 2, 3, 3 and 4. So after removing these self loops, my diagram will become like this. Now, next step is you have to remove transitively implied edges. What are those? 1 is related to 2, 2 is related to 3. I have 1 is related to 3. So anyhow, if I want to reach 3 from 1, I can do it by going from 1 to 2 and 2 to 3. So I don't need this direct edge from 1 to 3. So this transitively implied edge is removed. Same for this edge from 2 to 4 and the edge from 1 to 4. So after removing them, I will get this diagram. So now next step is you have to assume the arrows are directed from bottom to top. So you have to assume that the arrows are going from bottom to top. So you also remove the arrows. So now your diagram will look like this. So these are points, not vertices. Points. And this is your final Hasse diagram for your relation R. You can also retract this step backwards to get your original diagram of the relation. Okay, so this was an example. Now you can try drawing the Hasse diagrams for these examples. First is the divides relation on the set S. Second is the subset relation. The set is ABC and the set poset into consideration is the power set of this set S. Pause the video and try to draw the Hasse diagram for these. Okay, so I hope you might have tried drawing the Hasse diagram. First is the divides relation. This will be the obtained Hasse diagram for your relation. So here if you see 1 divides all other elements in the set S. That is why it will be at the bottom. Why? Because from 1 I can reach any other element through the intermediate points. So if I want to reach 12, I can go from 1 to 3, 3 to 6, 6 to 12, or by any other route. I don't actually need 1 to 12. So it is removed in the transitively implied edges step. Again, the elements 2 and 3, they are not comparable. Why? Because neither 2 is divisible by 3 or 3 is not divisible by 2. That's why they are occurring at the same level, because they are incomparable. Same for 6, 4 and 12 8. Okay, so this is your divides relation Hasse diagram, and you can observe that the elements at the bottom, if I can reach from 1 to 2, that means 1 is related to 2, 1 is related to 3. Again, 6 is at the bottom of 12, so I can write 6 is related to 12, which is a tuple in my relation, and so on. So the arrows are going from bottom to up. But you cannot go from 1 to 2 and again 2 to 4, 4 to 12, 12 to 6. You cannot go backwards. Only you can go forwards. So I can also go from 1 to 2, 2 to 6 from here. You can go topwards, but not from top to bottom is not allowed. So this is how you interpret the Hasse diagram. Next is the subset relation of S. These are the subsets. Null set A, C, B, AC, AB, BC, and ABC. So as null set is the subset of all other sets, that's why it is at the bottom. topmost is the set itself, base set itself, S. And the intermediate sets A, C, and B, they are non-comparable. Why? Because they are not subsets of each other. So that's why they are kept at same level. Same for these three sets A, C, A, B, B, C. And I can traverse. Okay. So phi is the subset of set B. Phi is the subset of set BC. Phi is the subset of set AB, and so on. Okay. Set AC is a subset of ABC. Okay. So likewise, A is also a subset of AB, B is a subset of AB, and so on. So this is how you interpret the Hasse diagram. So whatever set you are given, you just have to follow these previous steps that were given to you, and you will be able to draw the Hasse diagram. So a lot of practice is required. However, it is quite doable with a lot of practice.